Today we want to look at sinusoidal graphs. That's graphs of sine and cosine. The reason that we care is that sinusoidal graphs are good for modeling things that come in waves. Or that's good for modeling waves. So waveforms or periodic functions. So if we have some kind of phenomena that repeats at a regular interval, then we might want to model it with a sine or a cosine function. This is why we spent so much time learning the unit circle from 0 to 2 pi so well. Because once we go from 0 to 2 pi, we're still on the same circle from 2 pi to 4 pi. So anything that happens from 0 to 2 pi happens again from 2 pi to 4 pi, from 4 pi to 6 pi, from 6 pi to 8 pi, and so on. So if we can figure out what's going on in one cycle, we can figure out what's going on in all the cycles. So there are a lot of places that we'll see graphs of sines and cosines. When we look at the waves, we want to figure out where high tide and low tide might be. We're going to look at some kind of periodic function. If we want to look at the amount of sunlight that the location is going to have, we're going to look at some kind of periodic function. If we just happen to be in trig class, if we said make this graph, then we're going to be looking at some periodic function. So we're going to spend some time looking at sines and cosines. The other benefit from this, from a more mathematical career standpoint, this is a great opportunity to look at how changes in the function produce changes in the graph. So the other thing we care about is changes in the function and the changes that produces in the graph. So let's start off by drawing the graphs of sine and cosine. Let's review drawing the graphs of sine and cosine. Let's draw what I'll refer to as the base model sines and cosines. So vertically, we're going to want to go from +1 to 0 to -1, and we're going to want to know where that half happens, where this gets split in half. So I want the highest points to be at, let's say, 1. Let's put that here. 1. I'm going to want to be able to locate 1/2. And here's going to be 0. And then I'm going to want a -1/2. And then a -1. That's vertically how we're going to split things up. I want 5 evenly spaced marks vertically, the top being 1, the bottom being -1, 0 in the middle. And I want to be able to locate 1/2. On the horizontal axis, I'm going to want marks every, I'm going to want 3 marks. Well, I'm going to want 3 marks in each quadrant. So I'm going to want to mark quadrants, and I'm going to want them 1/3. 4 quadrants split into thirds. Why don't I just start off by saying that? So I'm going to want, I don't want that compact. That would be too compact. So I'm going to split out the quadrants. So, and I want it split into thirds. So I'm going to mark 1, 2, 3, 4, 5, 6. There's a second quadrant. 7, 8, 9 is the third quadrant. 10, 11, 12 is the fourth quadrant. So horizontally, I want 4 quadrants split into thirds. Vertically, +1 and -1 split in half. So vertically, 1, 1/2, 0, -1/2, and -1. Horizontally, 4 quadrants split into thirds. mark our 4 quadrants. The 1, 2, first quadrant is done. 1, 2, second quadrant. 1, 2, third quadrant. 1, 2, fourth quadrant. So we're back to the beginning. Now we're going to use what we know about the coordinates going around the unit circle. So coordinates going around the unit circle. Let's follow the x coordinate around the unit circle. At 0, the x coordinate on the unit circle is 1. And the x coordinate is the cosine. So cosine will start off at 1. And when we get to at the end of the first quadrant, cosine is dropped down to 0. So think about the x coordinate drops down to 0. Then in the second quadrant, the x coordinate goes from 0 down to -1. In the third quadrant, the x coordinate goes from -1 back up to 0. And in the fourth quadrant, the x coordinate goes from 0 back up to 1. Think about the x coordinate as we go around the unit circle. Think about the x coordinate as we go around the unit circle. Remember that when we're past, we split this into thirds. So this first quadrant ends at either 90 degrees or pi over 2 radians. So the thirds are at 30 degrees and 60 degrees, or pi over 6 and pi over 3 radians. So I got 1 pi over 6, 2 pi over 6, 3 pi over 6 are my 3 evenly spaced, my 3/3 of that first quadrant. We're thinking of the x coordinates. If we remember how we draw sinusoidal graphs, we're at a half. Cosine of 60 degrees, or cosine of pi over 3 radians, is 1/2. And we set it up so that we can draw roughly a line cutting through the horizontal axis. So that when we're coming across the horizontal axis, that's 1/3 before and 1 after 0, the crossing, 1/3 after the crossing point is where we have a 1/2. I missed. I made the 1/2 easy to find, and then I missed. Now to draw the rest of the graph, once we get these almost lines kind of cutting through the middle, we make sure that we get the graph goes flat at our endpoints. And then we just smoothly connect the lines to the flat endpoints. And we give it a little bit of bend. So there's our graph of cosine. For sine, we do a similar thing. We just have different starting points. We are going to track the y-coordinate as we go around the unit circle. And the y-coordinate starts off at 0, goes up to 1 at the end of the first quadrant, back down to 0, then down to -1, and then back up to 0. That's the y-coordinate as we go around the unit circle. 0 to 1 to 0 to -1, back to 0. So it goes up, down, and then up again. Now to get the rest of the graph, we look at when the graph is going to be crossing through the x-axis or the horizontal axis. And that's where 1/3 of the way is where we hit the half. Here's a crossing point. So 1/3 of the way, we hit the halfway. 1/3 of the way, we're at halfway. 1/3 of the way, we're at halfway. Now we connect these 1/3 halfway points with lines because it's almost a line. So I connect the line through here. Kind of do asteroids and warp back over here. And then coming down through the middle here. We make sure at the top and the bottom, the graph is flat. And then we just bend the flat up into the line so it connects smoothly. So just bend the flat up into the line. And we just kind of eyeball our bends because it's really hard to find 0.8660 on a graph, and we only got marked 1.5. There's a quick review on drawing a nice sinusoidal graph. You want the vertical marked with 0, plus or minus a half, plus or minus 1. And on the horizontal, you want to see your 4 quadrants split into thirds. Because it's at those thirds that we're going to find the halfway. It's at those thirds where we're going to mark the 1/2. It's at the quadrant that we're going to be at 0, 1, or -1. How's everybody okay? So in orange, we've got a cosine. Cosine starts at the top. And then in green, we've got the sine. Sine starts at the middle and heads up. So up here, I'm going to write these as, I'm going to say this is y and this is x. So I'm going to say that this orange graph is the graph y equals cosine of x. And down here, this sinusoidal graph, the green sinusoid is y equals sine of x. Cosine of x starts at the top. That's the way we're going to think about it. Cosine of x starts at the top. Sine x starts at the middle and goes up. So these graphs go on forever both directions. So it's really weird to say starts, but that's the way we're going to think about it. What's going on at 0? Cosine starts at the top, sine starts at the middle, going up. We have a top, we have a bottom, and we have a middle, but there are two different ways that the graph interacts with the middle. It either crosses the middle going up or crosses the middle going down. So I'm going to refer to this up here as the top. Here in the middle as the middle. Down here at the bottom, I'm going to refer to as the bottom. The graphs only interact with the top and middle, the top and the bottom by bouncing off and going the other direction. But the graphs interact with the middle in two different ways. There's two kinds of middle, the middle going up and the middle going down. Not enough space. There are two kinds of middle, a middle going up and a middle going down. This terminology is more local terminology when you're in my particular trig class. It'll be like I'll search on YouTube, middle going up. Notice that the points are going to follow a sequence. We start at the top. The next place we're at is the middle going down, then the bottom, then the middle going up, then the top, then the middle going down, then the bottom, then the middle going up, then the top. Wherever we start, that's the sequence of points that we're going to follow. So the sequence of points is going to be the top, middle going down, the bottom, middle going up, the top. Top, middle going down, bottom, middle going up, top, middle going down, bottom, middle going up, top, middle going down, bottom. I think you get it. Middle going up, top, middle going down, bottom, middle going up, top, middle going down, bottom, middle going up, top, middle going down, bottom. I can stop. Middle going up, top, middle going down, bottom, middle going up, and so on. And it just repeats. That's the sequence. Top and bottom only get to change direction, but the middle shows up in two different ways. Middle going up, middle going down. Okay. Felt up wrong. So this is what I mean when I say cosine starts at the top. The sequence will be top, middle going down, bottom, middle going up, top. And repeat. How's everybody okay? Just naming parts right now. We've unboxed our IKEA parts, and we're just making sure that we're matching up all the parts that they're supposed to give us with the parts that we have in the box. Look at the picture of the parts and the parts in front of us, make sure that they all match. So these are the three locations vertically I'm going to refer to: the top, the middle, and the bottom. We talked about making changes in the function and producing changes in the graph. So I'm going to name the distance from the middle to the top and the distance from the middle to the bottom. They're going to be the same distance, and we're going to call it the amplitude. Amplitude will be the distance from the middle to the top, or from the middle to the bottom, or from the bottom to the middle, or from the top to the middle. So amplitude will be the distance from the top to the middle, or the middle to the bottom, because they will be the same. So that distance we are going to call the amplitude. Our default amplitude, not really a default, but the amplitude that we have for cosine and sine that I'm going to refer to as the default amplitude, our base model amplitude is 1. That's the distance from the middle to the top. That's 1. 1 up here and 1 down below. So the default amplitude is 1. The default amplitude is 1. So when I have y equals cosine x, the amplitude is 1. Y equals sine x, the amplitude is 1. That's distance, kind of measuring the graph vertically. So next we need to measure the graph horizontally. Horizontally, we're going to look at the length of one cycle. So period is going to be the length of one cycle. Period will be the length of one cycle. That's from point to matching point, from top to top, or from middle going up to middle going up, or from bottom to bottom, the length of one cycle. This is a horizontal length. from point to corresponding point. Point to similar point. The important thing to remember is that amplitude is a vertical size, period is a horizontal size. So from middle going up to the next point where the middle is going up. Period is your horizontal distance. Amplitude is your vertical distance. Period is horizontal size. Amplitude is vertical size. The default period for sine, so just the period of sine and cosine, the default period is going around the circle one time. The default period is 2 pi. Default period is 2 pi. This is going around the circle one time. Okay. And in parts. I want to associate amplitude with the top, middle, and the bottom. That's a vertical thing. Amplitude is a vertical thing. Period is the length of a cycle. That's from point to corresponding point. Top to top, bottom to bottom, middle going up to middle going up, or middle going down to middle going down. Ran out of space like horizontally. And then I like said, and many more. Even there was like one more. Listed 3 out of 4, and there's like space underneath for the fourth one. I did myself an AM Gold advertisement. For those of you who don't get that reference, there used to be advertisements on television. I don't know if that's even true anymore, but there used to be advertisements on television. If you stayed up late enough and watched television late enough at night, some company would take a bunch of songs and make a mixtape and then sell you the mixtape that they made. And then they would list the songs on this 7 CD collection. And they would just like start listing the songs. And it's like 7 CDs worth of songs. And so they'd list like 60 songs. And at the very end of the list, they put like plus 3 more. And it's like, oh, dude, you just listed like 60 songs. Just put the last 3 on there. Are you trying to build some kind of anticipation? You know what I mean? I mean, how would you feel if like there's 40 people in the room and I named everyone but like the 3 people in this row? I'm like, oh yeah, here's who's here at class today. And I just start listing everybody's name and everybody's getting applause. It's like graduation, right? It's graduation. All these people are graduating, right? It's like, all right, so-and-so, student B, student C. And then I get down to this row, I call plus 3 more. That'd be fucked up, right? But that's what happens on like the advertisement for AM Gold. It's like, here are 60 songs that are in this collection. And there are 3 more, which makes me wonder, how bad are those 3 songs? But what are those 3 songs that you don't want to tell us about? Is it because they're awesome? No, it couldn't be, because they would have put that first. They say, oh, this song is definitely on this. Like, oh, I'll just buy it just for that. Because you just have to do that, right? Like the only form that music would be released is like a big collection of songs, one of which was any good. So if you wanted that, you have to buy the whole CD, then like whatever dollars on the CD. Certainly after CDs were a thing, like stealing from CDs was a thing, so I didn't do that. But that was the theory. So it couldn't be that. It must be that those 3 songs were so bad they would stop you from buying the album if you knew what they were. So. Yeah. Any questions on the shape of the graphs, the sequence of the points, and what we're trying to measure, amplitude and period? All right, let's take a pause and come back. And when we come back, we'll talk about messing with these values and seeing what happens.